Hi, my name is Eji. I'm an engineering student at Lausanne School of Engineering. In this video, I will be demonstrating my EECS 1011 project in which we require to water a plant. So, starting off with my codes, as you can see, for the first. The code starts with the while statement, in which a while statement I used to indicate that the value, as long as the soil is dry, the value would be true, equal to 1. And so, as you can see, the if else if statements and the these values are true, so they're equal to 1. And then for the else if statement, it detects if the previous if statement was false. Since it's true and not false, it displays a value of soil is damp, a bit more water needed. And then an else statement it ensures that the else statement ensures that since the if and else if statements were both true, the else if statement then ensures that the value is equal to 0 and that the statement is false, meaning the loop would come to an end. And then using an if statement, I also use my mathematical knowledge to determine that the soil, once the soil moisture is below 2.8 volts, the watering process stops. Finally, I used and sound detector, giving a signal to the user that the watering process is complete, no further action is required. Now, relating to the learning outcomes, I've demonstrated a solid foundation in EECS 1011, where I've used algorithms. All the algorithms you see here, I've specified specific values for dry, damp, wet, and which makes sense because, as I said before, once the moisture value is below 2.8 volts, the watering process would come to an end. The second learning outcome is that I've learned and demonstrated fundamental constructs of procedural programming, such as variables and expressions, control structures, and documentation. So as you can see, I used many mathematical expressions, including inequalities, in which once like the voltage is greater or equal to dry, the command window would display please water a bit more. For learning outcome 4, which is programming, I learned how to write simple programs using an integrated development environment, in which, as I mentioned before, I used the buzzer sound for integration. And then finally, for computational thinking, I've learned how to think and solve engineering problems, in which I've learned how to water a plant in the appropriate way. And lastly, implementing applications, I've learned how to use a computing environment to implement or simulate applications from science, math, and engineering, in which I stated before, I use many types of math, engineering, including science, in which I did research about how to properly grow and water plants. So now let's test my code. yeah, it takes a bit of while for the Arduino kit to connect. So as you can see, first of all, the moisture sensor is not connected to the plant, because from my previous test, the plant is already water. So I wanted to show how a dry value would look like, including the voltage values it display. So as you can see, it varies. Now if I were to show a damp value, yeah, as you can see, the table was already wet. So as soon as the moisture sensor detected water, the loop came to an end, as you can see, the soil moisture was below 2.8 volts.